Hey everybody, Mr. Zamora here. What we're going to do today is we're going to look at this worksheet that my Algebra 2 trig class was given earlier today. So the first side of this paper says determine if the following graphs could possibly be a graph of the polynomial function with degrees 3, 4, or 5. So without further ado, let's get right into it. So if I go to number 1 here, now automatically I'm going to put degree 4 as no, because if we remember from the rules of a polynomial graph, is that if it looked something like number 2 here, which we'll get in a second, as you can see, number 2 is different than number 1 in terms of where the graphs are going. Now, the left-hand side on number 1 is going down. It's going in one direction, and then for the right-hand side of the graph, it's going up, so it's going in the opposite direction. Now, if we know the rules on polynomial graphs, we know that it's not going to have an even power. It has to be either to the third, to the fifth, to the seventh, etc. Now, another way to determine this, it says if it could possibly be a graph, but what I'm going to do here is that I'm going to count the amount of curves that it has. So there's 1, and then there is 2. And we know that if depending on how many curves there are, if we count those and add 1, that's actually going to be the degree of that polynomial. So, and you can also look at the x-axis right here. I'm not sure how well the camera's picking it up, but you can count the zeros on the x-axis, so that'd be 1, 2, and 3. Now there could be some imaginary numbers here, but in this case we're not really going to focus on that. So I'm going to put yes for degree of 3 because both of these are going in opposite directions and they have 2 curves. Degree 5, that could be potential, but in this case we're not actually going to focus on that. So if we go into number 2 here, as I just explained earlier, both of these graphs are heading in the same direction. Looks kind of like a W. Now one thing that you could do, you can also count the zeros on the x-axis. So that'd be 1, 2, 3, and 4. So I'm going to put yes for this one, and then I'm going to put no for the rest of them. All right, so let's go on to number 3 here. Now, number 3 is a little bit interesting. So once again, just like number 1, it's going in opposite directions. Now let's count the amount of curves that it has. So that's 1, that's going to be 2, 3, and 4. 1, 2, 3, 4. We add that to one more. We add 4 plus 1 to determine the degree of that polynomial. So 4 plus 1 we know is going to be 5. So I'm going to put yes for this one and then put no for the rest of them. It's not going to be degree 4 because both of these are not in the same direction. They're not pointing in the same direction. They're both going opposite. This one's going up, that one is going down. And we know that because there's also 5 zeros right here and there's also 4 curves, that's not going to be a degree 3. All right, so let's focus on number 4 here. Now, number 4 is a little bit interesting. This one is actually heading down in the right-hand side, and this one's going up in the left-hand side. But no problem with that. What I'm going to do is I'm going to also count the curves. So it's 1, 2, 3, and there's 4. So this is going to be a degree to the 5th power. So I'm going to put yes. We know because they're going in opposite directions, that's not going to be a degree 4, and that's not going to be a degree 3 either, because if we count the amount of zeros, it's 1, 2, 3, 4, 5 on the x-axis. Depending on how many zeros we have, that can also determine the degree of that polynomial graph. So now we go over to number 5, and we notice that both of these arrows are pointing in the same directions. They're both going up in this case. So automatically, that is a yes for degree 4, and that's going to be a no for degree 3 and degree 5. So there we go with the front side, and now I'm going to go to the back side here. Now, we are given f of x and g of x functions of polynomials, and we are asked to match the graphs with the equation and to not use the calculator. That is the one catch to this whole thing. So I'm going to look at part A here. Now, part A should be pretty straightforward. It's asking f of x equals 2x minus 3. Well, we know that there's a constant right here, and we know that the highest degree polynomial is 1. Now, if we remember from a linear term, it's just going to look like a line. So let's see. Okay, that's not a line. That's not a line. Ah, there we go. So we can probably assume that this B point right here, point B, is 3, and then we can potentially use rise over run, but as long as we know that that looks like a line, we can determine that that point is going to be A. So let's cross that one out. Now let's go over to C actually. I was going to go over to B, but we'll focus on that one a little bit later. So the highest degree of this one, it says negative x to the 4th plus 6x squared minus 9x squared. Oh, it looks like that could be a little bit of a typo there because we'd actually have to combine like terms. Let's say that one's just x cubed. Looks like a little arithmetic or a typo error, no big deal. So that'd be negative x to the fourth plus 6x cubed minus 9x squared plus 2. Now, if we look, the highest degree is going to be 4, which we know is also a quartic, but we notice that there's a negative sign right here. Now, typically, when you graph these, it's going to look something like this. But if the leading coefficient in this case is negative, it's actually going to look like this, something like that. It's going to form from like a W to an M in this case. Now, we also know that this is going to have potentially 4 zeros. So let's look here. Okay, that could be possible. That's a parabola. We already know that one. The degrees are opposite. That is another parabola. And if that was the case, then the x would have to be positive. So the only one we have left is C. So C matches with this one, and then A matches with that one. I think that'll be easier so we can match them. So we can cross out C here. Now let's go over to G of x. Now this says G of x equals x squared minus 4x plus 7. Well, instantly what I'm thinking is that I think we can try to factor this out here. So let's say x squared minus 4x plus 7. But here's the thing, 7 is a prime number, which means its only divisors are going to be 1 and 7. And no matter if you add them or actually take the product of these two, you're not going to get a negative 4. So what does that mean exactly? Well, that's actually going to give you imaginary numbers. Now, you could use the quadratic formula right here, but in this case, I'm not actually going to do that. What we can determine, though, is that we're going to have imaginary numbers. Now, imaginary numbers on a graph like this are not actually going to come in contact with the x-axis. So let's look. We already solved for this one. All right, so you can kind of see right here, this one actually doesn't touch the x-axis right here. So I'm going to put E for this case because we can see that there are no zeros that actually touch the x-axis. It's kind of hard to see, but if you had the worksheet in your hands, you would actually be able to see it a lot better. So I'm going to cross E out. And now let's go over to B. This says G of x, which equals x cubed minus 4x. So instantly what I'm going to do here is I'm going to do x cubed minus 4x. Now what I'm going to do is I'm going to factor out an x right here. So that's going to give us x squared minus 4. And looks like we have a difference between two squares. So I'm going to take x and then I'm going to times that. Pardon my big hand in the way, sorry about that. X minus 2 and then x plus 2. So this one is going to be x equals 2. That one's going to be x equals a negative 2. And because we factored this x out earlier, that's just going to be x equals 0. So 1, 2, 3. And we know that this is also going to be a cubic polynomial, which means that the behaviors of the graphs are going to be opposite. So it's going to look something like this. Oh, that was a terrible line, but I think you guys got the picture. All right, so let's see here. All right, so we did these three. Oh, that one could be potential. That can't work because the behaviors are the same, and that's an upside down parabola, which means it would have to be quadratic. So the only option left is this one, so I'm going to put B for this case. And now we have 2 left here. So let's focus on part D right here. So D says G of x, which is equal to negative 2x squared plus 3x plus 1. Now here's what I'm going to do. So I'm going to put negative 2x squared plus 3x plus 1. Now what I'm going to do is that I'm going to actually try to factor this out. I'm not sure if that's going to be possible, but we can, it's all trial and error here. It's kind of like when we were doing synthetic division, trying to see what was going on. So negative 2 and then actually that's going to be negative 2x. And then times x, that's going to give us a negative 2x. And put this 1 right here. And that's going to give us a, let's say it's going to be a negative 1. And also another negative 1. Let's see if that's going to do anything. That's going to be a 2x. And that's also going to be a negative x. That actually doesn't work. But regardless of that, the only 2 options we have left are this one and that one. And if we look at part D, we know that that's a quadratic. And whenever you graph a quadratic polynomial, you know it's going to look like a U in this case. But because the leading coefficient is negative, it's going to look something like that. So it's going to go concave down, I guess you can say. So the only option we have left is choice, no, not choice anything. It's just like a regular graph here. So I'm going to put D in this case. And then lastly, just to make sure that we have everything, Part F is asking f of x, which is equal to x to the fourth power minus 5x squared plus 4. Now the leading coefficient we know is positive, and whenever you have a positive leading coefficient, it's going to look something like this if it's to the degree of 4, or quartic in this case. And the only option left we have is this one, so now we have choice F for this case. So that is the entirety of the worksheet, actually. So we have C, E, A, B, F, and D. And then if we also look on the front here, we solved these earlier because we counted up the curves, and we also looked at the amounts of zeros that we have on each of the graphs to determine if these could possibly have a function or a degree, in this case of 3, 4, or 5. So I appreciate you guys for watching this. I hope this was informal. So thank you for watching, and I shall see you soon.